The term fingerprints is a generic term generally used to refer to the intricate ridge formations on the palmar and plantar areas of the hands and feet. The ridges form lines that flow over your palm and fingers in very specific patterns and provide the function of improved friction, which allows you to grip objects that you pick up. These ridges are also referred to as papillary ridges or friction ridges. There are three basic pattern types: loops, arches, and whorls. In arch patterns, the ridges enter upon one side of the finger, make a rise or wave in the center, and flow or tend to flow out upon the opposite side. A loop is that type of pattern in which one or more ridges enter upon either side of the finger, recurve, and pass out or tend to pass out upon the same side the ridge entered. A whorl pattern consists of one or more ridges which make a complete circuit with two delta areas. Within these basic patterns, the friction ridges can fork into another ridge or form enclosures, end suddenly, or appear as a single ridge segment or dot. These specific characteristics of the friction ridges are called minutiae. Your friction ridges are formed before you are born and remain unchanged throughout your life unless altered by disease or injury. Friction ridge formations are unique to each individual. Not even relatives will have exactly the same formation of ridges. The ridges are made up of individual building blocks fused together to form continuous ridges. This results in very unique microscopic formations of the edges of the ridges. Minute details such as the relative position, shape, and size of sweat pores on the ridges are also responsible for providing very unique characteristics. As your hands sweat or you touch things in your environment throughout your day, the ridges become coated. When you touch an object, a partial impression of your friction ridges is transferred to that object, creating a recording of your ridges and their characteristics to form a fingerprint. Very often, ordinary objects are used or handled during the commission of a crime, and by comparing the impressions found on these objects to known impressions taken from individuals, the identity of the person or persons who last touched it can be determined. Sometimes these impressions are visible with the naked eye, and sometimes they can be seen only by using an alternate light source. At other times, scientists must use various chemical methods to develop these latent impressions in order to make them visible and preserve them by high-resolution digital photography. Law enforcement agencies send items of evidence to the lab to be processed for fingerprints. Evidence received in the latent print section of the laboratory will undergo several chemical processes depending on the substance the item is made of. For example, a plastic water bottle or metal soft drink can are non-porous items and would be treated differently than paper or cardboard, which are porous. The latent print scientist critically examines any prints that were developed during processing to determine their quality. This involves much more than simply looking at the impressions and requires extensive training and attention to detail. The examiner painstakingly judges whether the impression provides enough information to be compared to any known fingerprints. If the latent print is determined to be of value for comparison, it is compared to known fingerprints. These known fingerprints can be those of the victim or the subject, depending on the circumstances of the case. The latent print examiner evaluates the results of their comparison. There are three possible conclusions. It can be determined that a particular individual left this print. It can be determined that a particular individual did not leave this print. Or it can be determined that there is not enough information present to reach either of these conclusions, meaning the results are inconclusive. If there are no subject prints to compare the latent to, and the latent print is of good quality, then a computerized search can be performed using state and federal AFIS. AFIS stands for Automated Fingerprint Identification System and is a large database for storing, comparing, and updating fingerprint information on known criminals. The latent print scientist scans their unknown latent print into the system and selects specific data points for the search, for example, pattern type and minutiae. The computer system searches the database for the characteristics selected by the scientist and generates a candidate list of possible matches. The latent print examiner compares the unknown latent impression to the possible candidates and then makes the final decision as to whether any of these possible prints match their submitted latent print. In the event that no hits are generated by this search, the latent print can be registered in the unsolved latents database. This allows the unknown latent print to be searched against any new entries to the APHIS system. The GBI latent prints section also plays a major role in the identification of human remains by assisting medical examiner staff in obtaining fingerprints from badly decomposed or mummified bodies. The bodies can be identified by comparing the fingerprints to known impressions of possible missing persons provided by the investigators or by searching the fingerprints on APHIS. The criminal justice system and the community rely heavily on the information provided by the latent print examiners of the GBI. Persons may be implicated or exonerated by their findings. Additional persons of interest can be developed that were not previously known. Cold cases can be solved by future comparisons, and families can be provided with the whereabouts of a deceased loved one. Latent prints have been and will continue to be invaluable evidence.